Hi everyone, I'm Renee Weber and I am the payloads lead from the Artemis internal science team, and I'm pleased to bring you an update today on our candidate payloads for the Artemis 3 mission. Next chart. I just wanted to start off by briefly harkening back to the Artemis 3 science definition team activity. You may remember that in our report, we laid out a notional program for surface science, capturing the highest priority science for these sortie style missions and providing the greatest feed forward to follow-on missions. So that program contained three cohesive elements: sample collection and return, in situ and field science, both of which you heard about from my colleagues just prior to this presentation, and lastly, deployed instruments. And a successful surface mission really hinges on addressing all three of these program elements. This photo here is something that we worked in collaboration with the HLS project, showing the Starship HLS. And at the time, what we had to offer was sort of just a generic, an abstract payload. And I'm very pleased to announce that, we are well on the road from bringing this from the abstract to the concrete. So if I could get the next chart, please. Now, Lori did steal just a tiny little bit of my thunder in her presentation to open up this workshop. But these are the four payloads that we are in the process of developing and testing for the Artemis 3 mission. From left to right, we have LEMS. LEMS is the Lunar Environment Monitoring Station, and this is a seismometer suite. So LEMS is going to characterize the moon's seismicity and internal structure and assess both local and global seismic hazard, which is, of course, important as we are building towards sustained missions. LEMS is being developed at the University of Maryland in partnership with Goddard Space Flight Center. After LEMS, we have LDA, which is the Lunar Dielectric Analyzer. LDA is going to measure the dielectric properties of the regolith under differing thermal conditions. So hoping to take advantage of potential shadowing as the moon progresses through its illumination cycle to look for frost formation and possibly deposits of water ice. So LDA is our international contribution being developed at the University of Tokyo. After LDA, we have LEAF, the Lunar Effects on Agricultural Flora. So this is a plant growth experiment, and LEAF will investigate the effects of the lunar surface environment, in particular thermal, illumination, and radiation environment, on the growth of model space crops, so helping us figure out how we can grow food on the moon. This is being developed by a private company called the Space Lab Technologies. And lastly, we have ALLURE, the Artemis Lunar Laser Retroreflector. So ALLURE is going to improve constraints on the structure of the moon's deep interior. It is a great payload to go in tandem with LEMS, as they are both geophysical instruments that help constrain the moon's internal structure. And ALLURE is being developed by Goddard Space Flight Center. Okay, next chart, please. So we are, as I mentioned, well along on track with development and integration of these payloads. Really notable, I would like to highlight that last month we successfully completed the first Artemis deployed payload test involving a suited human in the loop. So all four of our payload teams participated in this event, which took place at Johnson in the Argos facility. Argos is the Active Response Gravity Offload System. So we took hardware mock-ups that are mass accurate, and we're able to test the payload handling and deployment concept of operations with a test subject in a pressurized spacesuit. So that was a very, very successful test. Like I said, it really makes it real when you start to see actual physical hardware in hand. Unfortunately, I don't have any pictures yet to show from that event, but hopefully we'll be able to get those out soon. The picture that I have shown here is some additional testing that the LEMS team did while they were, taking advantage of being at Johnson to test the seismometer deployment in the simulant development lab. And so that is what you see there. It is the hole that is left behind by the core sampling tool that Brett mentioned earlier. And one of the seismic instruments will be deployed down that hole. And so they're measuring the hole there. Coming up, I think by the end of this month, all of our payloads will be at the PDR level. A couple of them are a little bit past that already, but by the end of the month, they'll all be at PDR. And additionally, all payloads will have completed their phase 1 safety review, which is very important milestone, especially on the human exploration integration side. By this time a year from now, we hope to have, by March a little bit less than a year from now, we hope to have our training units delivered. And then targeting a payload delivery late next year for a mid-2027 targeted launch. That is the HLS launch because the payloads launch integrated on HLS. So that's all the updates that I have today. I just wanted to close with a reminder that we do anticipate that all data from these payloads will be archived and made publicly available. And we're greatly looking forward to that future involvement from the broader scientific community. Thank you.